To factor, I always start off by looking for the greatest common factor. After that, I count how many terms I have. If I have 2 terms, I'm always looking for the difference of 2 perfect squares. Now, in order to know what I'm looking for, I need to know what those words mean. In math land, difference means subtraction. So I'm looking for a subtraction of 2 perfect squares. Now, what are perfect squares? Well, perfect squares are any number that can be broken down to some number times itself. A perfect square can be written as some number times itself. Because any number times itself, that would make a square, like a 2 by 2 square. Both sides are the same. So here's a list of the first 16 perfect squares that we should probably be aware of. If we're relatively aware of these numbers, looking for the difference of 2 perfect squares is a lot easier. 1 is a perfect square. 1 is the god of our math land, I call 1. It is a perfect square, it is a perfect cube, it is a perfect everything, because 1 to whatever power is still 1. Just a nice little side note. 2 squared is 4, 3 squared is 9, 4 squared is 16, etc. So I have the list here of the first 16 perfect squares. And then we also need to remember that x squared here at the end is also a perfect square, because that's what the square means, is it's x times itself. Any number times itself is a perfect square. That's why we call the little exponent of 2 a square. So let's look for the difference of perfect squares and see how that's going to factor. Here is an example of a binomial, 2 terms, that the directions will say to factor, that we have the difference of perfect squares. First of all, once again, we look for the greatest common factor. There's an x here, no x here. Here is a 4, so we have factors of 1, 2, or 4. But the number in front of x squared is a 1. Remember, there's always a number there. 1 times anything gives us anything. So between 1 and 4, there's no greatest common factor. So now we look to say, how else can I rewrite this as a product or a multiplication? And this is actually our FOIL method working backwards. That's why it's really important that you focus in on what the FOIL method is so that you can then go backwards this week. So if you recall, the FOIL method last week was rewriting our two binomials being multiplied together as a trinomial or a polynomial that you multiplied inside. Well, here we're going backwards. We're going to rewrite this as a product of 2 binomials. Writing it as a product of 2 binomials. Alright, that's what our factoring is in essence going to be doing for us. Writing things as a product of 2 binomials. Now, you'll notice that we don't have that middle term on this one. That's actually beneficial to us. As what we're going to have instead is just our first and our last. And we can work this backwards. We can say what number times itself gives us x squared. We say, well, x squared is made up of x times x. And then we need to say, okay, what 2 numbers will multiply to a -4 and add to 0 since I don't have a middle term? Well, in order to get a -4, one of my numbers has to be positive and one has to be negative. Doesn't matter which one you put first and which one you put second. Now, 2 numbers that multiply to 4 but add to 0, if I use 1 and 4, that's not going to get me 0. The only way that we get 0 is if we add opposites. Same number, but one's positive and one's negative. And that's why we need a perfect square. Because what number times itself, same number, gives us 4. It's 2 and 2. Now we have this in factored form. X plus 2 times x minus 2. Let's prove it to ourselves by foiling it to show what we get. Okay, this is our check. FOIL method. Take the first times the first. X times x is x squared. Then you do your outside. So really the FOIL method is taking this x and distributing it through. X times the negative 2 is a negative 2x. Then you do the inside and you distribute the same way. 2 times x, it's a positive 2, so this makes it positive 2x. And a positive 2 times a negative 4, times a negative 2 is a negative 4 for your last terms. The middle terms are opposites. Negative 2x plus 2x is not x, it's 0x. And 0 times anything is 0. So that term goes away. They cancel each other out. That's how you end up with just the two terms. We have the x squared minus 4. So there it checks. So what was the answer again? The answer is this product in factored form. Things that are being multiplied together is factored form. So x plus 2 times x minus 2 is equal to our x squared minus 4. And that's our factored form. Let's do another. If we have x squared minus 49, once again the first thing I look for is a greatest common factor. We don't have any here, so then I count how many terms I have. I have 2 terms. The first term is an x squared, that's a perfect square. My second term is 49. Now if you need to go back to your list of numbers of perfect squares, you can do so. And right there is 49. 1, 2, 3, 4, 5, 6, 7. 7 times 7 is 49. So that's a perfect square, and we are subtracting the 2 terms. So this is clearly the difference, subtraction difference of 2 perfect squares. So then I can factor it. It factors to the root of both of these. What do I do to get x squared? X times x. What times itself is 49? 7 and 7. To get a negative, I need 1 positive, 1 negative. It does not matter which you put first. You could put x minus 7 times x plus 7. The importance is that the quantities are in parentheses and that you have one of each sign. So either or would be correct for that one. Let's do a little bit more of a difficult problem. Once again, I'm first looking for the greatest common factor. I do not have a greatest common factor, so the next step that I look for is how many terms do I have? I have 1, 2 terms. So now I look to see if they're perfect squares. 81 is a perfect square. I have a difference. X squared is a perfect square, and 4 is also a perfect square. Every factor in both terms have to be perfect squares in order to factor by the difference of perfect squares. So I know that this is factorable. I make my 2 sets of parentheses. What times itself gives me a 4x squared? It's going to be a 2x and a 2x. What times what gives me 81? It's a positive 9 and a negative 9. And just like that, you have that factored. Feel free to FOIL the check. Here's another one to start looking at. Now, if we first of all go straight to the point that, oh, I have 2 terms and I'm subtracting, I must be doing the difference of perfect squares, we might miss something, because 27 is not a perfect square. And for that matter, 48 is not a perfect square either. You need to remember that whenever the directions say to factor, the first thing you always look for is the greatest common factor. It'll make your number smaller, easier to handle, and it'll let you go further in the factoring. So what goes into 27 and 48? Well, that's going to be 3. If I pull out a 3, what am I left with? 27 divided by 3 is a 9, and the x squared still comes along for the ride. Minus, how many 3's are there in 48? 16. So now I have a greatest common factor of 3 on the outside, and I have this binomial inside. Now the binomial inside is now the difference of 2 perfect squares. So I can go further. This is not factored completely. This was just having the first step taken out. It's a product 3 times this entity, but it's not factored completely because I can go further with this. So what happens with the 3? Nothing, but don't lose it. It comes along for the ride. but I can break apart the 9x squared minus 16 into two binomials. I go through and say 9x squared is made up of 3x times 3x, and a negative 16 is made up of a positive 4 and a negative 4. Now I can't go any further because these only have x to the first powers, so now I'm done. Don't lose that 3, it's still part of my answer. So when factoring by group, when you're factoring with two terms, make sure that you realize that you have the difference of two perfect squares, but you might need to look for a greatest common factor first. Last problem that we'll do for this section of two terms. Once again, the first thing we're looking for is a greatest common factor. 49 is 7 times 7. That's not looking very good. And 144 is 12 times 12. So it doesn't look very good either. So now we can see, do I have the difference of two perfect squares, and we can break it apart. At this point, a lot of students say, oh yeah, sure, it's 7x minus 12 and 7x plus 12. But that doesn't give us a positive 144. Oh, then it's 7x plus 12 and a 7x plus 12. Well, try foiling that out once. Do you get 49x squared plus 144 as your final answer? Remember to do all stages of your foiling. Well, that gives me my 49x squared. The outside I have 7 times 12 is 84x. Inside I have another one of those, and then I have my 144. Now be careful. Does your middle terms cancel out in this case? Does 84x squared plus 84x squared make 0? No, this is adding. They're both positives. 84x plus 84x is 168x. It does not give me 0x. So this is not factored correctly. Okay. Remember, you can only factor two terms if you have a difference or subtraction. Because this one's being added, you can't factor it further. It's already done. I think your book calls it prime. Okay. Because there's a plus sign, you cannot factor that further. Keep that in mind when looking through the two terms. You need to have a difference of two perfect squares. If you don't have perfect squares to begin with, maybe you have a greatest common factor. If you have a plus sign, you can't factor it at all, and it's done. And that is how you simplify factoring by two terms.